Let's see another example of global index calculation for two-dimensional grid. Here is the grid we are considering. We have 16 threads arranged into 2 thread blocks in X dimension and 2 thread blocks in Y dimension, each thread block having 2 threads in X dimension and 2 threads in Y dimension. The difference of this grid from the grid we saw in the previous video is that here thread blocks are also two-dimensional. This is the general equation we used to calculate global index in the previous example. In this example also, we are going to use this general equation, but each value calculation is going to be different than the previous case. When we access an array with calculated global index value, the memory access pattern is going to be depend on the way we calculate our global index. We can calculate global index in different ways, but we usually prefer to calculate global indices in a way that threads within the same thread block access consecutive memory locations or consecutive elements in the array. So with this in mind, I have written the needed global indices for each thread slot in this diagram. So here you can see within the thread block, threads calculate consecutive global indices. And when we access memory using these global indices, threads within a thread block will access consecutive memory addresses. So let me show you how to calculate TID value and offset values considering this preference. We use TID to represent unique ID considering a single thread block. Since we had one-dimensional thread blocks in previous calculation, we were able to use threadIDX.X value directly for this value. But here, our thread block is two-dimensional. So we have to use equation shown here to calculate TID value in order to get values shown in this diagram. For example, for thread X in this thread block, threadIDX value in Y dimension is 1, blockdim.x is 2 and threadIDX.x is 0. So calculated TID value is 2, which is the value we expect. Block offset value can be calculated using multiplying number of threads in a block by block ID value in X dimension. Since we have two-dimensional thread blocks, we can calculate number of threads in a thread block by multiplying dimension value of a thread block. Row offset value can be calculated by multiplying number of threads in a thread block row by thread block IDX value in Y dimension. Number of threads in a row can be calculated by multiplying number of threads in one block by number of blocks in X dimension or grid dim value in X dimension. Okay, let's use this new value to calculate global index for our grid now. The implementation I am going to have here is almost similar to the one we had in the previous example. So let me copy that code here and change the kernel name to unique index calculation 2D2D. Now we need to change these offset values calculations. Our TID calculation can be done by multiplying threadIDX.y by blockdim.x and adding threadIDX.x value. Block offset value is the number of threads in block multiplied by blockIDX.x. So let's add another variable called number of threads per block. And its value can be calculated by multiplying block dimension values. Now we can set block offset value here. Row offset is the number of threads in each thread block row multiplied by block ID value in Y dimension. So here let me add another variable called num threads in a row, and its value can be calculated by multiplying number of threads in a thread block by number of thread blocks in row or griddim.x value. Okay, that's it for our kernel implementation. Now in the main function, we have to launch the kernel we discussed in the presentation. So we have to change block variable to two-dimensional one with 2 threads in each dimension. And also we are going to have 2 thread blocks in both X and Y dimensions as well. Okay, let's run this example now. Okay, in the output you can see global index value has been calculated uniquely. Therefore, our threads are able to access unique element from the array.